Episode 2, Symmetry Properties in the Pythagorean Identity. Let's get started. So let's start off with symmetry properties. The unit circle is divided into 4 quadrants. In quadrant 1, tan theta, cosine theta, and sine theta are all positive. In quadrant 2, sine theta is positive, cosine theta is negative, and tan theta is negative. I'll explain why. Sine theta is the y coordinate. So sine theta will always be positive when the angles range between quadrant 1 and quadrant 2. And cosine theta is only positive in the first and fourth quadrant because the x values are only positive at these points between the angles from here in quadrant 1 to quadrant 4. And tan theta is positive, and tan theta is only positive in quadrant 3 because tan theta equals sine theta divided by cos theta. In quadrant 3, sine theta is negative and cos theta is negative. So negative sine theta over negative cos theta equals tan theta. To remember this, we use an acronym known as CAST. C meaning cosine's positive in the fourth quadrant, A meaning tan theta, sine theta, and cos theta are all positive in the first quadrant, S meaning sine theta is positive in the second quadrant, and T meaning tan theta is the only positive value in quadrant 3. Now the exact values, here's a chart right here. Pi on 6, sine pi on 6 at a half, cos pi on 6 is root 3 on 2, tan theta is 1 over root 3. We derive all these exact values from the special triangles. This is pi on 3, pi on 6, and pi on 2. This is the special triangle. This is where we can derive pi on 6 and pi on 3. This is the first special triangle. The second special triangle is this one. Pi on 4, pi on 4, 1, root 2. This is where we derive sine, cosine, and tan pi on 4. And pi on 2, sine pi on 2 is simply what this value is. Pi on 2, sine pi on 2 over here is 1, cosine pi on 2 is 0 because there's no x value here, x is 0, and tan pi on 2 is undefined. Now the first question is asking us to evaluate cosine and sine in radian form. To figure this out, we're going to have to break this up. Cosine 3 pi on 4 equals cosine pi minus pi on 4. To evaluate this, we need to find the exact value. Cosine pi is this. And if we subtract it, we're in the second quadrant. So cosine, the exact value is the same as negative cosine pi on 4, which equals 1 over root 2. Negative 1 over root 2. Similarly, sine 5 pi on 4. This is the same as sine pi plus pi on 4. Let's picture this. This is sine pi, and this is sine pi plus pi on 4. Sine is negative in the third and fourth quadrant, so this value is the same as negative sine pi on 4. This equals negative 1 over root 2. Sine 25 pi on 2. This is the same as sine 24 pi on 2, so it's sine 12 pi plus pi on 2. Let's picture this. Sine 12 pi on 2 means that you're going through 6 full revolutions plus pi on 2. At this point, this is the value of sine 25 pi on 2 is, so as I was saying, this is equivalent to sine 12 pi plus pi on 2. 12 pi means that we're going through 6 full revolutions. This is 2 pi multiplied by 6. 6 full revolutions. And then this is sine, okay, this is sine 12 pi plus pi on 2. At this point, sine is equal to 1. Because this value here is the equivalent of sine pi on 2. So sine equals 1. Sine 15 pi on 6. This is the equivalent of sine 12 pi. Let's break this up. Sine 12 pi on 6 plus 3 pi on 6. This equals sine 2 pi plus pi on 2. Let's picture this out. This is sine pi, sine 2 pi, and sine pi. This exact value is 1 because this value is equivalent to sine pi on 2. Sine is positive in this quadrant, so we can just say sine, this value, the exact value of this is equivalent to sine pi on 2, which equals 1. Cosine 17 pi on 4. This equals cosine, let's break this up, cosine 16 pi on 4 plus pi on 4. Now cosine 16 pi on 4 plus pi on 4 is equivalent to cosine 4 pi plus pi on 4. Now if we visualize this on the unit circle, that is equivalent to 2 full revolutions, 2 pi, 2 pi, 4 pi, 2 pi, 4 pi, plus pi on 4. The exact value of this is in the first quadrant, and this means that cosine 4 pi plus pi on 4 is equivalent to cosine pi on 4. And this equals to 1 over root 2. Sine negative 15 pi on 4. Sine negative 15 pi on 4 is equivalent to negative 16 pi on 4 plus pi on 4. This equals to sine 4 pi, negative 4 pi plus pi on 4. Now let's find the exact value. Negative 4 pi means 1 pi, 2 pi, 3 pi, negative 4 pi plus pi on 4. So the exact value of sine negative 15 pi on 4 falls in the first quadrant, and in the first quadrant sine is positive. So this is equivalent to sine pi on 4, which equals 1 over root 2. Sine 27 pi. Sine 27 pi is equivalent to sine 26 pi plus pi. So this means sine 26 pi plus pi is equivalent to 13 full revolutions plus pi. So let's say this is 26 pi, 13 full revolutions, plus pi, which makes this value 27 pi. At this point, the sine is 0 because the x value would be 1, negative 1, cosine would be negative 1, but sine would be 0. So sine 27 pi equals 0. Sine negative 17 pi on 3. This value is equivalent to sine negative 18 pi on 3 plus pi on 3. This value equals to sine negative 6 pi, negative 6 pi plus pi on 3. Negative 6 pi means you are making 6 full rotations around the unit circle in the negative direction. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi and negative 6 pi. Negative 6 pi plus pi on 3 means you are moving back up in the other direction, positive direction, and the exact value of sine negative 17 pi on 3 is here. Because it's in the first quadrant, again, sine is positive. This value, the exact value, is equivalent to sine pi on 3, which equals to root 3 on 2. Cosine 17 pi on 6. This value is equivalent to cosine 72 pi on 6 plus 3 pi on 6. This equals to cosine 12 pi plus pi on 2. Cosine 12 pi plus pi on 2, the exact value is equivalent to finding 6 full revolutions plus pi on 2. This is the exact value of cosine 75 pi on 6. At this point, cosine is 0. Cosine negative 15 pi on 6. This value is equal to cosine negative 12 pi on 6 minus 3 pi on 6, which equals to cosine negative 2 pi minus pi on 2. Let's visualize this real quick. Cosine negative pi, negative 2 pi, and negative pi on 2, which makes the value of this essentially equivalent to cosine negative pi on 2 equals negative cosine pi on 2. And at this point, cosine is 0 because sine is negative 1. There's no x value. X is 0 at this point. If this is p theta, cosine is 0. The x value is 0 and y equals negative 1. So cosine, negative cosine pi on 2, or cosine negative 15 pi on 6 equals 0. Sine negative 35 pi on 2. This equals to sine negative 34 pi on 2 minus pi on 2. This equals to sine negative 17 pi minus pi on 2. Let's visualize this. Because, here's an easy trick. Because this is an odd number, we know that we wouldn't be making a full rotation back to the origin, meaning the value of negative 17 pi would end at this point. So demo, okay. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, 12 pi, 13 pi, 14 pi, 15 pi, 16 pi, and 17 pi. If it's an odd number, if the value of pi has a negative coefficient, it's always going to end up here. But if it's a positive number, it's always going to end up back at the origin. So negative 17 pi on 2 minus pi on 2 is this value. At this point, sine, the exact value of this is sine pi on 2 because we are in the second quadrant. In second quadrant, sine is positive, so sine pi on 2 equals 1. Cosine negative 4 pi on 6. This is equivalent to cosine negative 42 pi on 6 minus 3 pi on 6. This equals to cosine negative 7 pi minus pi on 2. So as I said, because it's a negative coefficient, we're going to end up here and minus pi on 2. Minus pi on 2 brings us back here. Sine is 1, cosine is 0. This equals 0. Cosine 16 pi on 3 equals cosine 15 pi on 3 plus pi on 3. This equals cosine 5 pi plus pi on 3. Negative coefficient, so we're here, we're going in the positive direction, so we're going to be here. Cosine 5 pi on 3. We're in the third quadrant, so this is equivalent to negative cosine pi on 3, which equals to negative 1/2. Let's just move this here, negative 1/2. Sine negative 105 pi divided by 2. This equals to sine negative 104 pi on 2 minus pi on 2. This equals sine negative 52 pi minus pi on 2. Let's visualize this. This is a positive coefficient, so we're back here. We're moving in the negative direction. So we're going to have this value. This value here is the exact value of sine negative 105 pi divided by 2. This point sine equals negative 1. But for modeled working, we'd want to write, because this is in the fourth quadrant, we would say that this is equivalent to negative sine pi on 2. Pi on 2 is 1, which equals negative 1. Cosine 1035. Because this is a negative coefficient, we know that this equals negative 1. Now this is the same thing. This is the same thing as before, but now we are using degrees. So this sine 135 degrees equals to sine 180 minus 45 degrees. Let's picture this right now. We've got sine 180 degrees minus 45 brings us here. This angle theta equals 135 degrees, and the exact value, because we're in the second quadrant, sine is positive, so let's say the exact value is sine 45, which is equivalent to sine pi on 4, which equals to 1 over root 2. And if we rationalize this is important for the exam. You don't want to lose marks for not rationalizing the denominator. This would equal to times root 2 over root 2, which equals to root 2 over 2. Remember this for the exam. You do not want to be losing marks because you did not rationalize the denominator. Remember that. Okay, cos negative 300 degrees. This equals to cosine negative 360 plus 60. Let's picture this. So we're going a full rotation, negative 360 degrees, but then we add 60 degrees, which brings us here. Because cosine is positive in the first quadrant, the exact value, theta, the exact value is equivalent to cosine 60. Cosine 60 equals cosine pi on 3, which equals to 1/2. Sine 480, this equals to sine 360, 420 plus 60. This is the, okay, no, let's do a better one. Sine 360 plus 120. Let's picture this right now. So we've gone a full revolution, and 120 degrees ends here, and we derive the exact value from this angle, right? This angle here, theta, sine is positive in the second quadrant, so the exact value is sine 60. It's equivalent to sine 60, because this angle here is 60, 120, the exact value is here, so sine 60 equals root 3 on 2. Cosine 240. Cosine 240 equals to cosine 180 plus 60. So if we pull up the unit circle, we're going 180 degrees plus 60 right here. Let's make this alpha. Alpha is 60, theta, this entire angle, is 240. Now the exact value here, we're in the third quadrant, so cosine is negative. The exact value is negative cosine 60, which equals to negative 1/2. Sine negative 225. This is equivalent to sine negative 180 minus 45 degrees. Let's picture this. Sine negative 180 minus 45. So theta, let's make this theta and this alpha. Theta is negative 225 and alpha is our reference angle. Now our reference angle here, 45 degrees, is in the second quadrant. Sine is positive in the second quadrant. So this is equivalent to sine 45, which is 1 over root 2. Sine 420, let's break this up. Sine, this equals to sine 360 plus 60. So we're going a full revolution around the unit circle, 360 plus 60. We stop right here. Our reference angle here is 60 degrees. So that's how we derive our solution. Sine is positive in the first quadrant. So this is equivalent to sine 60, which equals to root 3 on 2. Now the second part of this video is the Pythagorean identity. The Pythagorean identity states that sine x squared, sine squared x plus cos squared, cosine squared x equals 1. Explain why. Over here, let me just draw the circle. We've got our unit circle over here. Our radius is 1. Let's make this dotted line. This is p theta. This is sine. This value is sine theta, cos theta. This is the right angle. So using the Pythagorean theorem, we can derive this as sine squared theta plus cos squared theta equals 1 squared, because 1 squared still is 1, sine squared theta plus cos squared theta equals 1. That's how we derive this formula. This is the radius of the unit circle, which is always 1. The y value is sine theta. X value is cosine theta. Let's try this question out. If sine theta equals 0.5 and pi on 2 is less than x is greater than pi on 2 and less than pi. Okay, so we're trying to find an angle that is less than pi but greater than pi on 2. So it's in the second quadrant. Let's do the Pythagorean identity. I'll just remind you one more time. Sine squared x plus cosine squared x equals 1. 0.5 squared plus cosine squared x equals 1. Now looking on my calculator, 0.5 squared equals 0.25. 0.25 plus cos squared x equals 1. Cosine squared x equals 0.75. We're subtracting 0.25 from both sides. And this is cos squared x. Cosine x is the square root of, let's fractionalize this, this equals 3 over 4. Cosine x equals, it's a square root of 3 over 4. Cosine x equals root 3 on 2. Now because we know that we're trying to find an angle in the second quadrant, cosine is negative. So as I was saying, because cosine is negative in the second quadrant, Let's try this working down. Because x, okay, let's write this in, okay, gradient form, okay. Pi on 2, yep, x is greater than pi on 2 but less than pi cosine x equals negative root 3 on 2. Now tan x is derived from sine x equals sine x divided by cosine x. So 0.5, which equals 1/2, this equals 1/2 divided by negative root 3 on 2. This equals to 1/2 times negative 2 over root 3. This equals to negative 1 over root 3, which equals negative root 3 on 3. Remember to rationalize. Okay, next question. Let's state the identity again. Sine squared x plus cosine squared x equals 1. This time we know cosine x. Right. Sine squared x plus negative 0.7 squared equals 1. Before I continue any further, let's establish what our domain is. So x is less than 3 pi and 2 but greater than pi. This is pi, this is 3 pi and 2, so we're looking for an angle in the third quadrant. Let's continue. 0.7, negative 0.7 squared equals to sine squared x plus 0.51 equals 1. 0.49, sorry, 0.49 equals 1. So sine squared x, let's subtract this from both sides. Sine squared x equals 0.51. Let's write this as a fraction. Sine squared x equals 51 over 100. So sine x must equal to root 51 over 100, which equals root 51 over 10. Because this angle we're looking for is in the third quadrant, sine is negative. Sine is negative in the third quadrant, so because, let's rewrite this, pi x 3 pi on 2 sine x equals negative root 51 on 10. Now let's find tan x. Tan x, again, is derived by dividing sine x from cos x. So sine x, which is negative root 51 on 10, divided by cosine x, which is negative 0.7, which is negative 7 over 10. So let's do this. This equals to negative root 51 over 10. This equals to negative root 51 over 10 times negative 10 over 7. Let's cancel this. Cancel the minus signs. This equals root 51 over 7. On to the next question. Sine x equals negative 0.5. Our domain again is between pi. X is greater than pi. Pi is right here. This is 3 pi and 2. So we're looking for an angle in the third quadrant. This time we have sine x. We don't know cosine x, and we need to find cosine x and tan x. Let's get started. Okay. Sine x squared plus cosine x squared equals 1. So negative 0.5 squared plus cos squared x equals 1. 0.25 plus cosine squared x equals 1. cosine squared x minus 0.25, subtract 0.25, cosine squared x equals 0.75. This is, let's fractionalize this now. Cosine squared x equals 3 over 4 cosine x equals root 3 over 4 cosine x equals root 3 on 2. Now, because this angle is in the third quadrant, we know that cosine is negative here. So now we're going to write, because the domain, okay, pi x is great, because x is greater than pi and less than 3 pi on 2, we can say that this value of cosine is negative. So cosine x equals negative root 3 on 2. Tan x equals sine x divided by cosine x. This equals to sine x negative 0.5, which equals negative 1/2 divided by negative root 3 on 2. This equals to negative 1/2 times negative 2 over root 3. Let's cancel this. This equals to 1 over root 3, which equals to root 3 over 3. Last question, guys. The domain for this one, 3 pi on 2 and 2 pi. So x is less than 2 pi. X is less than 2 pi but greater than 3 pi on 2. So we're trying to find an angle in the fourth quadrant. Sine x squared plus cosine squared x equals 1. We know sine x, this is negative 0.3, so negative 0.3 squared plus cosine squared x equals 1. 0.09 plus cosine squared x equals 1. Cosine squared x equals 0.91. Now let's fractionalize this answer. Cosine squared x equals 91 over 100. Now cosine x equals root 91 over 100. Cosine x equals root 91 over 10. Now because cosine is positive in the fourth quadrant, we're going to say because 3 pi on 2 x 2 pi. Because x is greater than 3 pi on 2 and less than 2 pi, cosine x equals root 91 over 10. Now let's find tan x. Tan x equals sine x over cosine x. This equals to sine x. Okay, sine x. Sine x is negative 0.3, which equals to negative 3 over 10 divided by root 91 over 10. This equals to negative 3 over 10 times 10 over root 91. Let's cancel this. This equals to negative 3 over root 91. Let's rationalize the denominator now. Times root 91 over root 91. This equals to negative 3 root 91 over 91.